Hello friends, I Professor Darshan Thakur welcomes you on my YouTube channel for the subject head Digital Communication. Friends, in this session we will try to learn the basics of this modulation scheme, probably which is used in case of wireless communication for telecommunication or for radio communication. The name of this special modulation technique is nothing but the spread spectrum technology, right? So as far as our today's area of discussion is concerned, so we will try to learn the basic mechanism of this modulation scheme, spread spectrum technique, as well as the need of this spread spectrum technique, means why we are going for this spread spectrum technique, and the generalized block diagram of this spread spectrum technique, right? So before going for this basic mechanism of this spread spectrum technique, let us consider one situation in which, if suppose we are interested to transmit an information bearing signal with minimum bandwidth, or whenever it is required to transmit the band limited signal through any kind of channel, either it is wired channel or wireless channel. So in such type of scenario, we can have the so many challenges, or there are certain difficulties which are associated with this transmission of band limited signal or band limited information bearing signal, right? Means the challenges are nothing but what, as we are having the lowest data rate, or due to that the overall performance of that system is very low. So in order to tackle with such type of situation, we are in need of enhance the bandwidth of this information bearing signal over a larger frequency band. So this is the basic logic behind this spread spectrum technique. Means for faithful transmission of that signal, we are going to enhance the bandwidth of this transmitted signal as compared to the bandwidth of this input signal. Okay friends, so according to the basic definition of this spread spectrum modulation technique, in which the bandwidth of this transmitted signal is being enhanced as compared to the bandwidth of this input signal with the help of special spreading sequence, or we can call it as a pseudo noise sequence, or most of the time that can be called it as a PN sequence. So in lateral part we will try to learn how that desired spreading sequence or the PN sequence is being generated. For sake of this moment, we are supposed to learn the basic mechanism of this spread spectrum technique, right? So let us consider, if suppose this is the bandwidth of this input signal, which exactly equals to how much? For sake of our convenience, if suppose it equals to capital B. Capital B is nothing but what? The desired bandwidth of this information bearing signal which we are interested to transmit, and whenever this frequency band is being passed through this spread spectrum modulator, basically SSM stands for the desired modulator, belongs to this spread spectrum technique. So when these signals are being passed to this modulator, so according to its definition, the bandwidth of this transmitted signal is being spreaded over a larger frequency band. So where BSS is nothing but what? The spread spectrum bandwidth of this transmitted signal, and according to the basic definition of this spreading sequence or the PN sequence here, this BSS equals to L times of capital B. So L equals to what? BSS upon B, right? So in this way, the spread spectrum technique works in case of analog system as well as in case of digital system, right? Because there are two different types of spread spectrum techniques we used to have with us. Out of that two types, first one is nothing but what? The direct sequence spread spectrum technique, and second one is nothing but what? The frequency hope spread spectrum technique. This direct sequence spread spectrum technique is nothing but what? The digital type of spread spectrum technique, and the analog type of spread spectrum technique is nothing but what? The frequency hope spread spectrum technique. So we need to understand the objective behind this spread spectrum technique is to enhance the bandwidth of this transmitted signal, and if we are increase the bandwidth of this transmitted signal, so obviously which will have the certain advantages, like we can achieve the highest signaling rate or the highest data rate, which is to be explored by this spread spectrum technique in case of this analog system as well as in case of this digital system, right? So this is the basic mechanism of spread spectrum technique, in which the bandwidth is being enhanced over a larger frequency band with the help of a certain spreading sequence or the PN sequence, or we can call it as a pseudo noise sequence, right? So this is the basic mechanism of the spread spectrum technique, right? Then after that we will try to learn the generalized block diagram of this spread spectrum technique. The bandwidth utilization or the effective utilization of this available bandwidth is nothing but what? The basic need behind this spread spectrum modulation technique. Because as far as this bandwidth utilization is concerned, so usually whether it is analog communication or the digital communication, there are two possible ways. By means of these two ways we can effectively utilize the available transmission bandwidth. So out of that two technique, first one is nothing but what? The different multiplexing technique, and the second one is nothing but what? The different multiple access technique. Because as far as this multiplexing techniques or the multiple access techniques are concerned, again it is a very big area of discussion. Because multiplexing means what? The frequency division multiplexing, time division multiplexing, or the code division multiplexing, or the wide division multiplexing, right? These are the different multiplexing scheme generally we do have with us in order to effectively utilize the available transmission bandwidth. And as far as this multiple access schemes are concerned, so the multiple access schemes are nothing but what? Like the frequency division multiple access, or we can have the time division multiple access, code division multiple access, right? So this spread spectrum technique is specially used in case of this code division multiple access technique, right? For the purpose of bandwidth utilization. So let us quickly go through the generalized structure of this modulator and demodulator, or we can call it as a transmitter and receiver. Okay friends, so after going through the basic mechanism as well as the need of this spread spectrum technique, let us quickly go through the modulator and demodulator, or the generalized block diagram of this spread spectrum technique, right? So this is how the modulator will look like, and that is nothing but what? The demodulator, or we can call it as a spreader and despreader. So similar to the continuous wave digital modulators which we had discussed in earlier session, whether it is single carrier or multi carrier, like binary phase shift keying or the quadrature phase shift keying or the quadrature amplitude modulation, right? Such type of modulator we used to have, which consists of two identical test signal. One is nothing but modulating signal and another is nothing but what? The carrier signal. Here this digital modulating symbol sequence is to be modulated with the help of this spread spectrum modulator, which consists of these two identical blocks, right, which we are having with us, right? These two blocks are nothing but what? The frequency synthesizer and the PN sequence generator. So basically a multiple number of frequencies we used to have within this frequency synthesizer block. It is being operated with the help of this PN sequence generator, or that pseudo noise sequence or the spreading sequence will decide the particular frequency which is used to modulate the digital symbol sequence by means of spread spectrum technique. Means if suppose this is the bandwidth of this input signal, right, according to the basic definition, right? So after being passed through this spread spectrum modulator, the resultant signals which are being emitted by this modulator, whose bandwidth is exactly equals to how much? Here BSS, right, where BSS equals to what? This L times of capital B, where this L is nothing but what? That can be called as a processing gain, or the length of this spreading sequence generated by this PN sequence generator, right, or generated by pseudo noise sequence generator, right? According to this generator, the particular frequency is being selected by that synthesizer, and after that this signal is being combined with this input signal to generate the resultant signal. So this is how the modulator works. Similarly, as far as this demodulator is concerned, so again it is a coherent type of demodulator. So it will try to adopt the same PN sequence which was adopted by the spread spectrum modulator for the purpose of despreading or for the purpose of demodulation, right? So here initially the received symbol sequence is being given to one of the input of this demodulator, and its lower part consists of this frequency synthesizer as well as the PN sequence generator, right? As it is a coherent detector, because we do have a certain sort of synchronization in terms of modulator and demodulator, and finally we can demodulate the desired output data, because this is only the generalized discussion of the spread spectrum technique. In lateral part we will try to discuss the analog spread spectrum technique as well as digital spread spectrum technique, which are nothing but what? The direct sequence spread spectrum technique and the frequency hope spread spectrum technique, right? So I hope you will understand all these basic things belongs to this spread spectrum technique. Thank you.